As NASA starts wrapping up one moon mission, they're already gearing up for what comes next. But recently, the agency's leadership dropped a bit of a surprise. The next mission in the Artemis program is likely facing a delay. So, what's actually going on here, and why is this happening? At a budget hearing, NASA Administrator Jared Isaacman said the two companies building the Human Landing Systems, HLS, needed to get astronauts down to and back from the Moon, SpaceX and Blue Origin, have indicated they'll be ready for a rendezvous and docking demonstration in Earth orbit by late 2027. Let me remind you, Isaacman reconfigured the Artemis program on February 27th, making the next mission, Artemis III. He's been saying he wants launches on about a 10-month cadence, which would have put Artemis III in early to mid-2027. So yeah, this does point to a delay. So what's actually behind this delay? To understand that, we need to take a closer look at what Artemis III really involves. Where Artemis II was basically a test flight, sending humans around the moon and back, Artemis III is the next step. It'll start with a new crew of 4 astronauts strapped into the Orion capsule on top of the massive Space Launch System rocket. But this time, their destination won't be the moon.
Test the interoperability of the Orion spacecraft and the landers in low Earth orbit, where if something goes wrong, you're not all the way out there 250,000 miles away. You're just a couple hours from being in the water.
The new plan for Artemis III focuses on testing a potential lunar lander in space while staying closer to Earth, so there's a safety margin if anything goes wrong. The old plan, though, was to jump straight from Artemis II, which we've seen loop around the moon and come back, directly into landing people on the lunar surface with Artemis III. That honestly sounds incredibly risky. This updated approach makes the path to a moon landing a lot clearer and more step-by-step. It also means that alongside the launch of SLS and Orion, there could be 1 or 2 additional heavy rockets lifting off as part of the mission. NASA first awarded a contract to SpaceX back in 2021 for its Starship HLS, originally aiming to have it ready by 2024. Then, in 2023, Blue Origin got its own contract, targeting a first flight by the end of the decade. Now, NASA's basically trying to speed both of them up, just to make sure at least one system can actually land astronauts on the moon by the end of 2028, ideally before China gets there and before Donald Trump leaves office. The first thing to launch will be the moon landers. That means a Starship and a New Glenn, each deploying their upper stage lander into low Earth orbit. Now this is where the first big challenge shows up. Lunar Starship and Blue Moon are so massive that they burn a huge amount of fuel just getting from Earth toward the moon. So before they can actually land, they'll need to refuel in space. Otherwise, they won't have enough propellant to get the astronauts back off the lunar surface. So, as part of Artemis III, both companies have to prove they can successfully refuel a spacecraft in Earth orbit. For SpaceX, that means launching a second Starship to act as a fuel tanker. These newer V3 vehicles are already designed for this, with built-in docking ports, similar to the ones used for ground propellant loading, and the ability to use docking probes when needed. Once they're connected, the next challenge is managing the propellant in microgravity. Since liquids don't naturally settle at the bottom of a tank in space, both vehicles use small thrusters, either hot gas thrusters derived from Raptor tech or cold gas RCS, to create a very gentle milli-G acceleration. This tiny push is enough to force the liquid oxygen and methane toward the tank outlets, keeping everything where it needs to be. That settling force is maintained or pulsed throughout the transfer to avoid pulling in vapor instead of liquid. This exact technique was actually validated during an in-flight test on Starship Flight 3. With the propellant properly settled, the transfer itself can begin. Instead of using large, complex pumps, Starship mostly relies on pressure. The tanker slightly pressurizes its tanks higher than the receiving ship, which naturally pushes the propellant through the connecting lines and umbilicals. It's a simpler system that builds on what Starship already uses, and it's designed to move huge amounts of fuel, potentially hundreds of tons in a single session. Of course, keeping that propellant stable is its own challenge. These are cryogenic fuels, so they boil off easily. To deal with that, SpaceX uses a mix of subcooling before launch, strong insulation, vacuum-jacketed transfer lines, and fast transfer times. They'll also need longer orbital test flights to really understand and minimize boil-off over time. After the transfer is complete, the two ships undock. The tanker then deorbits and heads back to Earth for reuse, ideally getting caught by the launch tower, while the refueled Starship continues on with its mission. Early demonstrations, expected around 2026 with these V3 vehicles, will likely involve launching two Starships close together. One will stay in orbit longer with extra power, acting as a target, while the second plays the role of the chaser and tanker. They'll dock, transfer a significant amount of propellant, possibly over 100 tons, and then separate. For Blue Origin, it means sending up a separate propellant transport vehicle. That adds at least 2 more massive rocket launches, followed by orbital docking and propellant transfer demos for both Lunar Starship and Blue Moon. No one has ever refueled a ship in space before, so pulling off 2 of these operations is a pretty big leap forward. As Isaacman put it, it's that capability that allows us not just to get back to the moon, but really build a moon base, putting lots of mass on the surface efficiently and affordably, not to mention everything else that comes from a rocket you don't have to throw away. The next challenge is docking the 2 spacecraft. The lander will be fully autonomous, while Orion will have a pilot at the controls. This is actually something they already practiced on Artemis II, where pilot Victor Glover carried out a mock docking by steering the capsule toward its own spent upper stage. Lunar Starship has its docking port right in the nose, so once the crew transfers over, they're stepping straight into a huge open space. A flight deck that's about 9 meters wide and several meters tall. Blue Moon, on the other hand, docks from the side, so the entry is a bit more traditional. Once the crew is on board, it's time to get to work. That means running a full shakedown of all the critical systems: life support, power, propulsion, and communications. It's not quite as complex as refueling in orbit, but it's still a really important step that has to be done right before any actual lunar landing missions can happen. Getting Starship and Blue Moon ready for a crewed mission is no small task. It's a pretty steep climb, honestly. If you look back at Apollo 9, NASA played it safe. 2 astronauts took the lunar module out for a spin, separated from the command module, and spent over 6 hours flying solo in low Earth orbit before docking again with the 3rd crew member. That kind of test was crucial before even thinking about landing on the moon. For Artemis III, something similar would be needed, but it's way more complicated this time around. Either Starship or Blue Moon would need to function almost like a fully independent spacecraft, with its own life support system, human-rated engines, a proper cockpit with flight controls, and a reliable docking system. And right now, neither SpaceX nor Blue Origin has shared much detail on how far along those systems really are. On top of that, there's the whole challenge of refueling in orbit, which adds another layer of complexity that's hard to ignore. Put it all together, and it's easy to see how things could slip. Honestly, when NASA talks about a late 2027 timeline, it does feel a bit on the optimistic side. That said, none of this automatically means the mission is going to slip again. There are actually a few upsides here, too. For Artemis III, if NASA decides to run a mission in low Earth orbit, just a few hundred miles up, it might not even need to use one of the existing SLS upper stages that are already built and sitting in storage. That would let them save one for a later Artemis flight that's actually aiming to land on the moon. On the flip side, going to a higher orbit would mean using that upper stage, but it also gives NASA a chance to test things in conditions that are a lot closer to what they'll face around the moon. So it's really a trade-off between conserving hardware and getting more realistic testing. Looking ahead, NASA is also planning to switch things up by bringing in the Centaur 5 from United Launch Alliance to eventually pair with the SLS once they've flown through the current batch of upper stages. So either way you look at it, there are some solid wins mixed in with the challenges. And as I mentioned earlier, NASA is also trying to speed things up by pushing both lander teams toward a simpler way of actually getting to the moon. One idea they've been looking at, especially with SpaceX, is a different mission profile that shifts a lot more responsibility onto Starship. Instead of the SLS sending Orion all the way to lunar orbit on its own, Starship would take on most of the heavy lifting. The plan would have Starship launch first, then refuel itself in Earth orbit, which is critical since it needs a huge amount of propellant for a full round trip. Orion would launch separately, rendezvous with Starship in orbit, and dock. From there, the astronauts would basically transfer over and live inside Starship for the journey. Starship would then fire up its engines and carry both itself and Orion out to low lunar orbit. Once they get there, Orion stays behind uncrewed, kind of like a parked ride home, while Starship takes the crew down to the lunar surface, supports them during the mission, and then brings them back up to orbit afterward. After that, the two vehicles dock again, the crew moves back into Orion, and Orion handles the trip home and re-entry. In this setup, Starship does almost everything, and at least for now, it's still treated as expendable by the end of the mission. One of the biggest advantages here is timing. In the original plan, Starship might have to wait around in lunar orbit for Orion to arrive, which isn't ideal. It uses super cold propellants that slowly boil off, so any delay could turn into a serious problem. If too much fuel is lost, you're suddenly talking about refueling near the moon, which is incredibly difficult. With this updated approach, all the critical steps happen much closer to Earth. Starship refuels in Earth orbit, docks with Orion there, and they head out together. If something slips, it's a lot easier to deal with. You can just send up another tanker and top it off. Fixing issues in Earth orbit is way more manageable than trying to solve them hundreds of thousands of kilometers away. Overall, it's a more forgiving plan. It reduces risk, uses propellant more efficiently, and gives the whole mission a bit more breathing room.